Good day everyone, let us now proceed to our new lesson, Introduction to Quadratic Functions. So we're now through discussing the different ways on how to solve quadratic equations like factoring, square root method, completing the square method, and quadratic formula. So this time, let us learn a new topic which is called the quadratic functions. MELC, or the most essential learning competency, models real-life situations using quadratic functions. Learning objectives: determine the models of quadratic functions, given equations, table of values, or graphs. Differentiates quadratic functions from linear function, and cite real-life situations that models a quadratic function. Definition of quadratic function. Quadratic function is a function that can be described by an equation of the form f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. In a quadratic function, the greatest power of the variable is 2. So as you can see here in the equation of a quadratic function, the greatest power of the variable x is 2. So in other words, quadratic function is called a second degree function. The graph of a quadratic function is what you call a parabola that may open upward or downward. So in this picture, you can see the graph of a quadratic function, which is called a parabola that opens downward. And here in this picture, a graph of quadratic function, which is called a parabola that opens upward. Okay, that's the definition, quadratic function. Here are the three forms of a quadratic function. They can be in standard form, y is equal to ax squared plus bx plus c. They can be in factored form, y is equal to quantity ax plus c times quantity bx plus d. And also, they can be in vertex form, y is equal to a times the quantity x plus b squared plus c. In our succeeding lessons, we will learn also how to convert standard form of quadratic function to its vertex form, or vice versa. Here are some examples of quadratic functions. Y is equal to 4x squared minus 2x plus 5. Okay, that's written in standard form. Number 2, y is equal to quantity x plus 7 times the quantity x minus 5. And that is written in factored form. We also have here quadratic function written in vertex form, y is equal to 3 times the quantity x plus 6 squared plus 2. So the three examples here, they are all what we call examples of quadratic functions. Identifying the quadratic function from the given table. We have here a table. This is the table for the ordered pair xy. For one side, okay, we have here 1, 2, 3, 4, 5, 6, 7, and the corresponding area for each side. For 1, 14, 2, 24, 3, 30, 4, 32, 5, 30, 6, 24, 7, 14. Okay. Let us try to identify if this table is a graph of a quadratic function or not. Okay, we look at the differences in x and y. For the differences in x, they are all the same, 1. Okay, if we're going to subtract 2 minus 1, 1, 3 minus 1, 1, 4 minus 1, 1, 5 minus 4, 1, 6 minus 5, 1, 7 minus 6, 1, 4 minus 3 I should say, which is all the same, which is equal to 1. So the differences in x, they are all equal. How about in the differences of y? First differences in y. 24 minus 14, 10. 30 minus 24, 6. 32 minus 32. 30 minus 32, negative 2. 24 minus 30, negative 6. 14 minus 24, negative 10. What did you observe? For the first differences in y, they are not the same. They are not equal. But if we're going to get the second differences in y, let's try. 6 minus 10, negative 4. 2 minus 6, negative 4. Negative 2 minus 2, negative 4. Negative 6 minus negative 2, negative 4. Negative 10 minus negative 6, negative 4. So, equal. The second differences in y for this table is equal, or equal I should say. First differences in x are equal. How about the second differences in y? They are also equal. So that's how we describe, or that's how we can tell that the graph, or yes, the given table is a graph of a quadratic function. So second differences in y, there is equal differences in x, but no equal first differences in y. However, there is an equal second differences in y. So that is how we can describe or identify quadratic function. Okay? Equal differences in x produce equal second differences in y. This is a characteristic of a quadratic function. Now let us identify whether the function is a quadratic function by writing q, and by writing nq if it's not quadratic. Write your answer on the space provided. So we have here numbers 1 to 10 given with the given function. Identify whether it's quadratic or not. If it's quadratic, write q. If it's not quadratic, write nq. So number 1, what's your answer? Dito na yung mga sagot. So for number 1, nq, it's not a quadratic because that's actually a linear function. Yes, linear function. Number 2, yes, it is a quadratic function because the highest exponent for the variable x is 2. Number 3, okay, this is a quadratic function in factored form, so q. Number 4, not quadratic because it involves a radical sign. How about number 5? Not also a quadratic. Okay. Number 6, not also a quadratic, it's a linear function. 7, it's a quadratic function. Number 8, it's a quadratic function. Number 9, it's not a quadratic function, and q, that's a cubic function. And number 10, it's a quadratic function. Right? It's easy to identify a quadratic function from not quadratic function. All you have to do is to try to see the exponent, the highest exponent for the variable x is 2. Now, write P if the graph is parabola and NP if it's not. Write your answers on the space provided. Number 1, is this a parabola or not? Answer. Yes, it is a parabola that opens downward. How about number 2? Is this a parabola or not? It's not a parabola, it's a straight line. It's a graph of a linear function. How about number 3? It's not a function. It's not a parabola because it's a B shape. B shape is not a parabola. It should have been a U shape. How about number 4? Of course, it's not a parabola. It's not a parabola. And 5, it is a parabola that opens upward. Okay. So number 1 and number 5 are the only graph of a quadratic functions. 2, 3, 4 are not the graphs of quadratic function. How about this? Write yes if it's quadratic function, and write no if it's not quadratic function after the item number. Number 1. Okay, these are given tables, so we're just going to identify the first differences in y and the second differences in y. So for quadratic function, the first it will produce equal first differences in x and equal second differences in y. Okay, may typographical error dito. Dapat x yan, x, 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 x. First differences in x. So let's start with number 1. What do you think? Is this table quadratic function or not? By just looking at the graph, describe mo yung first differences and second differences. So for number 1, no, it is not a quadratic function. Why? What is the... Okay, all the given tables here have first differences in y, right? 1, which is 1. 1, 1, 1, 1. Titignan na lang natin dito, second differences in y. if they are equal. So we have for number 1, okay, so for number 1, it is not a quadratic function because the second differences in y are not equal. 1, 1, 1, 1. First differences in y is 1, 1, 1 eh. 1, 1, 1. So 0, 0. Number 2, again no. Teka, kaya pala wala yung number 1 dito, nawawala. Okay, number 1 is missing here, so let's just skip number 1. The answer is no. But in this we'll start with number 2. The table for number 1 is missing, so let's just start with number 2. Okay, so for number 2, the first differences in y is 1, the second differences in y is 0, 0, 0. But still, it's not a quadratic function because it should have been the first differences in y should not be equal. Only the second differences in y are equal. Next, number 3. This is number 3. Again, 1, 1, 1 ulit dito. No? First differences, 1, 1, 1 ulit. No, again, first differences in y, 1, 1, 1, 1. Second differences in y is 0, 0, 0, 0. So again, this cannot be a quadratic function because only the second differences in y should be equal, not the first differences in y. How about in number 4 here? 2 minus 5, negative 3, 1 minus 2, negative 1, 2 minus 1, 1, 5 minus 2, 3. Okay, first differences in y, negative 3, negative 1, 1, 3. They are not equal. How about the second differences? Negative 1 minus negative 3, 2. 1 minus negative 1, 2. 3 minus 1, 2. So, equal second differences in y, but not equal in the first differences in y. So this is a number 4. Table number 4 is yes, it is a quadratic function. How about number 5? First differences in y, negative 3 halves, negative 1 half, 1 half, 3 halves. Yes, not equal for the first differences, but you subtract the second differences in y, we have 1, 1, 1. So it is number 5. Yes, it is a quadratic function. So only 4 and 5 tables represent a quadratic function. 1, 2, 3 are not quadratic function. Number 1 table is missing. So let's proceed to our next quadratic function. Yes, it is a second degree function of the form y is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. This is a function which describes a polynomial of degree 2. So we have here equation. We are now trying to differentiate between a linear function and quadratic functions. So when we say linear function, they are described by the equation of the form y is equal to bx plus c or mx plus b. Okay. So example, y is equal to 4x minus 1, y equals 6x plus 3. So, yeah. The highest exponent of x is only 1. And if the highest exponent is 1, it is a linear function. So, yes. There's an exponent, but it means 1. So, that is a linear function. How about the quadratic function? It's described by the equation of the form y is equal to ax squared plus bx plus c. Example here, y equals 4x squared plus 3x plus 2. Y equals negative 5x squared plus 4x. Y equals x squared minus 6. Y equals 4x squared. So the highest exponent must be 2. Okay, can you see the difference? Easy, right? When it turns to graph, what is the graph of a linear function? It's a straight line. It can be a vertical line, horizontal line, or slanting line, or diagonal line. The graph can be diagonal, vertical, or horizontal. How about the graph of a quadratic function? It is a parabola, opens upward and downward. If the graph of parabola does not open upward or downward, then the graph is not a quadratic function. Okay? Only upward and downward can be considered as quadratic function. Okay, intindihan? So, straight line for linear function, parabola for quadratic function. When it comes to table of values, linear function, equal differences in x produce equal differences, first differences in y. Yan ang linear function. Subtract from right to left in getting the differences in dependent variable x. Subtract from right to left in getting the first difference. So equal ang kanyang first differences in x and first differences in the y. Whereas in the quadratic function, we just discussed a while back, in quadratic function, when given the table, there is equal differences in the variable x, while it produces equal the second differences in the independent variable y. Okay, so as you can see here, first differences for x 1 1 1 1 1. First differences in y we have 1 4 7 10, while the second differences in y 3 3 3. So equal ang kanyang second differences. Okay, easy, right? So let us describe. Right, yes, if the graph is a quadratic function, and no, if it's not a quadratic function. So meron na tayong answer sa number 1, of course. Number 1 is not a quadratic function, it's a circular function. So no. Right, yes, if the graph is a quadratic function. No, if it's not. Excuse me. Number 2, what's your answer? No, I think that's a cubic function. Number 2. Number 3 is a parabola. It's a quadratic function that opens upward. How about number 4? Yes, it is a quadratic function, parabola that opens downward. How about number 5? What's your answer? No, it's a linear function. Number 6? No, I think that's a sine function. Number 7, yes, it's a quadratic function, parabola that opens upward. How about number 8? Yes, it's a parabola. Okay, but the answer is no, it's not a quadratic function. Why? Because it's a parabola but not a quadratic function because it does not pass the vertical line test. Okay, pag vertical line test, it will touch the parabola twice. So no, it's not. Also with number 9, no. Okay, parabola that opens to the left and right cannot be considered function because it does not pass the vertical line test. Only the parabola that opens upward and downward can be considered quadratic function, like in number 10, 7, 3, 4. Okay. Okay. 7 are an activity. Find the second differences of a quadratic function given the table of values. 1, 2, 3, 4, 5. Okay. What's your answer for number 1? Yun, equal differences. Negative 3, negative 3, negative 3. Okay, did you get the same answer? 9 minus 5, 4. 10 minus 9, 1. 8 minus 10, negative 2. 3 minus 8, negative 5. And then, second differences, all equal, negative 3, negative 3. So if we're going to graph this table, it will become a parabola. About number 2? 3, negative 1, 1, 3. And how about the second differences? Equal again. So that's a parabola. Number 3. Negative 1, 3, 7, 11 for the first differences in y. And second differences in x, in y I should say, are equal, which are all equal to 4. So that is a quadratic function. Number 4, here. Negative 1, negative 4, negative 7, negative 10. Equal differences in y, negative 3 all. And then it should be 1, 2, 3, 4, 5. Wrong numbering naman. So number tama pala. Ito, nalito ko dyan. So number 5, equal differences again in y. We have negative 1, 6, 13, 20. But if we get the second differences, 7, 7, 7. So all these tables, if we are going to graph, the graph is a parabola. They are all considered quadratic function. So that ends our topic on introduction to quadratic function. I'll see you next time. Goodbye.